Hi everyone. So today's lesson from Unit 9 is a little bit of a review of Algebra 1. So the first question asks you to label the graph with everything you remember from your Algebra 1 class. So some things you might recall are, first we have the horizontal axis, also referred to as the x-axis, and a vertical axis, which is our y-axis. And these two axes divide the coordinate plane, which is the whole graph, into 4 quadrants. In the upper right quadrant, that's number 1. And in that quadrant, both your x and your y value are positive. So you have a positive number for x, a positive number for y. In the upper left corner, that's quadrant 2. And that's where the x coordinate would be negative, and the y coordinate would be a positive number. Lower left gives us quadrant 3, where x and y are both negative, and lower right is quadrant 4, where to get there you would use a positive x value but a negative y value. Okay, you might also recall that this point of intersection of the two axes is referred to as the origin, and it has the coordinates 0, 0. So x is 0, y is 0. So next, let's take a look at how to graph some points. So for the point A, and this is a number 2, point A is at 4, 0. So you want to start at the origin and count 4 units to the right for x. 1, 2, 3, 4. And this tells us to use 0 for y, so we're not going up or down or above or below the x-axis at all. So label it with a point A, and you can even put the coordinates of the point after that. For point B, with coordinates 2, 3, the x and the y are both positive, so that means we're going to be in quadrant 1. So starting at your origin again, you want to count to the right 2, 1, 2, and then up 3. So point B would be right there, and again its coordinates are 2, 3. For point C, we're graphing negative 4, positive 5, so obviously x is negative, y is positive. That's going to put us over here in quadrant 2. But again, we start counting from the origin. Left 4, 1, 2, 3, 4, and then up 5. So way up here is point C with coordinates negative 4, positive 5. Finally, our last point, point D, is at 0, negative 4. So that means that while we start at the origin, we don't go left or right at all. We just go down 4 units. So there's point D. Again, 0, negative 4. So that's not in a quadrant, and neither is point A. We would say point A is on the positive x-axis, and point D is on the negative y-axis. So they're not in a quadrant, they're on one of the two axes. Okay, the next skill we're going to review is finding the distance between 2 points on a graph. So the distance between A and B, if I just draw that line segment, can be just found by counting because it's a horizontal line segment. So it's 1, 2, 3, 4 units long. So the length of AB is just 4. Easy enough. Okay, if we try to find the distance between C and D, notice that C and D are on the same vertical line. So in the same way that we found the length of AB, the length of CD can just be found by counting. So we go down 1, 2, 3, 4, 5, 6, 7 units. So CD is 7 units long. Right, now switching gears here for EF. Line segment EF is that line segment connecting those 2 points. Since this is along a diagonal, we can't find the length of it by counting, but what we can do is take a look at the horizontal distance, we've gone, and the vertical distance. And you can find those two distances by just counting. So this side will be 4, because there are 4 squares along that length, and this side is 3. Now notice that the vertical and the horizontal form a right angle. So what we can do to solve for the distance between E and F is use the Pythagorean theorem. So EF is the hypotenuse in this right triangle, so we're going to set it up as 3 squared plus 4 squared is equal to x squared. 3 squared is 9, 4 squared is 16, and together they're going to add to 25. So if 25 is equal to x squared, our next step is to take the square root of both sides, so we get x is equal to 5. So the distance between point E and point F is just 5 units. And again, you found that you can find that by turning it into a right triangle and using Pythagorean theorem. So we're going to apply that same idea to points G and H on our graph. So first connect those 2 points, and then look for a right triangle that you can use. So I'm going to go to the right and down. So there's my right triangle. The sides of the right triangle have lengths of 3, and this side is 1, 2, 3, 4, 5. Okay, again, label your hypotenuse with an x, and then we'll use the Pythagorean theorem. So do 3 squared plus 5 squared, and set it equal to x squared. 3 squared is 9, 5 squared is 25, and that's equal to x squared. 9 and 25 add to 34. All right, we have to take the square root of 34 and the square root of x squared. And in this case, the square root of 34 can't be factored or reduced in any way. So that distance between those 2 points, G and H, would just be given as the square root of 34.